Okay, we will start the section 3.5 and this will be the final part of chapter 3, right? So we are going to discuss the sine inverse, cos inverse and tan inverse functions, right? So actually sine inverse x is the what inverse function of sine x, like that, right? So here if you think of now sine inverse x, right, sine inverse x and x, right? So what should happen is we should have a y equal x, right, y equal x, and we should have a reflection. But we have trouble now, we discussed, right, discussed if we have for example, to get the inverse function, right, we can't have like this, right? Now this is a function, but it is many to one function, right? So if you put a horizontal line, there are two y values, sorry, there are I mean this is the same y value and there are two x values. So here we have the situation, same y value, right, same y value, there are two values which are coming for this, right? So we can't have the reflection. Then what would happen is, right, to I mean if you reflect this situation will come. So we can't have a function. So to have a function, what we can do is, I mean here minus pi over 2, right, minus pi over 2, that range. Now here we know this is the 1, plus 1 and minus 1, right? And if right here pi over 2, if we take this part, I mean remaining part, now I will erase the others, right? If you take this, now this is all right, right, this is all right. Then actually whatever horizontal line if you draw, right, it will cut only in one place. So we will consider this part and we will, others are actually repeating values, no, right? So here if you take that one and consider the reflection, the graph will come like this, right? And here it would be pi over 2, right, pi over 2 and minus pi over 2, minus pi over 2, right? Now we'll think, I mean cos we have a little trouble, but we will discuss first tan, right, tan. So tan we are, I mean if same trouble comes, now here if you put horizontal lines, you should consider only one curve, then that is okay. If you go for others, we are in trouble, right? So if we consider this part, the remaining part, that is also then will be pi over 2 and minus pi over 2. So our tan, I will draw it here, right? So this will be 1 and this will be minus 1, and if you take the reflection, it will go like this, right? And here also it is 1 and here it is minus 1, right? Now we have trouble, right? Now if you take now both cases, we took minus pi over 2 and pi over 2, right, pi over 2. But if you take that region here, actually the cos is like this, right? This is the, if you consider range, minus pi over 2, minus pi over 2 and pi over 2, then actually we can't reflect or take the inverse function. The reason is horizontal line is cutting two places, then we doesn't have a inverse function. So here to get that, actually what we should consider is 0 to, right, here pi over 2, pi over 2. So we should take the range, right, range of this, I mean it's a pi over 2. Wait, I'll check and let you know. right? Again I will explain that part. Cos x, right? Tan x, I will erase it, right? Cos x we are having like this, like this, right? So here it is going to be 0, and here it is going to be pi over 2, and here it is going to be pi up to this place, right? Pi. So always pi over 2 pi, and here another pi over 2, what would happen is 3 pi over 2. Here again minus pi over 2, and here 3 pi over 2 minus 3 pi over 2. So now what we should consider is, right now when you put a horizontal line, this part should vanish, right? So here we have pi over 2, 0. Up to 0 is all right, right? So we consider only this part for the cos inverse. So here this is cos x, right? And then when you reflect it, you will get, right? I will draw it here. When you reflect it, you will get oh, I mistake. Sorry, it will be on top of x-axis. So here it is top of y-axis, right? Like this, and like this, right? So it will be minus 1, 1, and the range will be 0 to pi, right? So I will erase this, erase this and draw these three things again, and pause the video and I will show what this looks like, right? Then we can have a clear idea. Now if you look at the three graphs, right, we will try to see the domains and the range. If you take sine inverse, right, the domain would be between minus 1 and 1, right? Minus 1 greater than or equal to x, less than or equal to minus 1, and it is same for cos. Minus 1 greater than or equal, less than or equal to plus 1, right? Here plus 1, right? Plus 1. And if you look at the tan, actually all the values are possible, so we can say x belong to R, right? Right. Now what would be the range? So actually the projection onto the y-axis, it would be between minus pi over 2. Now if you take the sine inverse minus pi over 2, right, we'll say y greater than, less than or equal to pi over 2, right? Here it is symmetrical. And if you take cos inverse, the range is greater than 0 and x y, right, y less than or equal to pi. And if you take again tan inverse, the range would be minus pi over 2 less than or equal to y less than or equal to pi over 2. So you should remember, even the calculator, actually when you take the sine inverse, cos inverse and tan inverse, it gives the output in this range. So from that you have to decide. If you take any value, the range would be between this sign, right? So if you take sine inverse and also cos inverse values, it will give between 0 and pi, and tan is also like sine. Right, now we'll go for some questions. Okay, before we go to the example 14, right, part A, we'll see whether we can understand this. So here what I told was sine inverse x domain will be minus 1 to 1, right, and the range will be between minus pi over 2 to pi over 2. So actually this is the graph which we studied, and here in this diagram actually I have put all the quadrants and its range, right, range I have put. So that means when you take sine inverse, for example, sine inverse something, right, the output or the value of this, now we are we are not thinking of the solutions, we are thinking of the value, sine inverse value of that, not the solutions, right? So that value should be between, I mean should be in these two quadrants. That means either minus pi over 2 or pi over 2. And here I have put when minus pi over 2 it is minus 1, and when that angle becomes 0, sine 0, I mean it is 0, and the answer is 0, right? Here it would be 1. And also same thing, cos inverse, we discussed the range, right? Domain also, now we know it's between minus 1 and 1. Those are the values we can inverse from cos. So his output, right, his output always, I mean above the x-axis, the value, so that value is actually 0 to pi, right? 0 to pi. So here then when angle is 0, right, angle 0, it gives cos 0 1. When it comes to here, cos 90 is 0, and here cos pi is minus 1. So that is shown here. So this shaded area is the range. Those are the outputs of this function, right? So it should always give in this range. And tan inverse, again his domain is any value you can have, right? Any value you can have, and his output will be always between minus pi over 2 to pi over 2. So this quadrant is represented. So when we have the output as, I mean minus I mean infinity, we are not here, but then it is then it is minus pi over 2. If it is plus in infinity, it is pi over 2, and if it is 0, then it's 0. So all the things are here. Now only thing what now, because this is little interesting, we have, I mean this one in exercise we will do, right? We have to have this idea when you are answering the sine inverse, not the solution. So here what we can do is sine inverse sine inverse root 2, we can simplify this inside value. So sine inverse, we will get minus 1 over root 2, right? So we know 1 over root 2 represents the 45 degrees, right? 45 degrees. So we'll say it is pi over 4. Now the trouble is we have to get minus, right? Minus. So the answer is, now to get minus 1 over root 2, we have to choose here. So the answer is, this is equal to minus pi over, sorry, here pi over 4 minus pi over 4, right? So then the part B of that is example 14, part B. They are asking us to find cos inverse minus 1. Part B, cos inverse minus 1. Cos inverse minus 1, right? So I mean, so we have to consider this, right? So what is the value which gives minus 1? That means pi. So this answer is pi, right? Pi. And also you can get it from here also, minus 1. So minus 1, for minus 1 it gives pi, right? Then part C, it asks tan inverse root 3. Tan inverse root 3, right? So now root 3 is a known thing, so we know, I mean you have to remember those tables, right? So root 3 is a known thing, so it's representing pi over 3, right? Now it gives positive value, so positive values are here, pi over 3, so the answer is pi over 3, right? Then we'll see that some interesting question is there. Now although these things are like that, now I will do the question 1 first, part G, right? This is page 64, exercise 3E, and question 1, part G. I will do part G, right? Part G is they are asking sine inverse, right? Sine inverse sine pi over 3, right? So this is obviously I mean, we can think of cancelling of this and put pi over 3, but we have to be very careful, right? If this angle, when you have this like cancellation situation, if this pi over 3 is in the range, right, if it is in the range, that's all right. But now I'll take the other one. So here what would be, what you have to write in inverse, first write sine pi over 3 is how much? Root 3 over 2, right? Then we can again write sine inverse, this one is pi over 3. I mean the same method. Now we have discussed these things in the other chapters also, right? So sine in root over 3 is sine, right? So in this range, so this is the positive value which we get, and this is the one which is given. These are the ranges which is given by the calculator also. Right, now see, if you take part H, it is a little tough one, right? A tricky one. Now here it says sine inverse sine, right, sine 2 pi over 3, right? But now if we just try to cancel it off and put 2 pi over 3, this answer is wrong, because now the problem is 2 pi over 3, actually it is more than pi over 2. 2 pi over 3 is actually how much? 360, 120 degrees. Now the range of, I mean the range of sine inverse, he can't have more than 90, so we are in trouble. So what we can do is this, right? Sine 2 pi over 3, I mean if we are going from the basics, sine inverse sine 2 pi over 3, right, that is equal to, right, sine pi, right, sine pi minus sine pi minus pi over 3, like this you can write, right? Now because 2 pi over 3, now when you simplify this, we get this. Now we know equation, right? We know sine pi plus or minus theta is minus theta, right? Sine pi minus theta is equal to sine theta. From that equation we can write here sine pi over 3, right? Or else you can put the value of this one, that also okay. Now actually you can kind of cancel off, right, and put the answer. So here sine pi over 3, actually we know it is what, 16 root. So sine inverse what, pi over 3 is what, 16 root 3 over 2, again it is equal to pi over 3, then it's all right. But now in this case, if we did the cancelling off method, this gives a wrong answer, because it's not giving answer in the range of sine inverse x, then it's wrong. Now here question 4 part A, it says cos inverse half and sine. So what we can do is sine cos inverse half is actually we can say, we will put in this pi over 3, right? Then sine pi over 3 is root 3 over 2, right? That is all right. Now we'll see negative 1 is there. Part B we will try, part B, question 4 part B, right? It says cos sine inverse sine inverse half, right? Cos sine inverse minus half, right? Sine inverse minus half. Now when we take minus half, it comes here, right? It comes here, right? Then what is sine inverse minus half? Sine inverse minus half is then cos. We will get minus pi over 6, right? Now cos, we know the equation cos minus theta is equal to cos pi over 6 from that equation. Now cos pi over 6 is root 3 over 2. Root 3 over 2. Right. Now in question 4 part F, we have sine and 2 sine inverse root 2 over 2. So what we can do is sine 2 sine inverse 1 over root 2, right? And then sine 2 into 1 over root 2 is pi over 4, right? So sine, then 2 into this one is pi over 2. So sine pi over 2 is 1. Okay, now we do the sixth question of page 65. It says sine inverse x is equal to k and k is between 0 and pi over 2. So here he is in the first quadrant, right? So so this is angle. No, it's in that and then it's asking state the range of possible values of x, right? So part A, possible values of x. So surely to get sine inverse x, right? Sine inverse x now if you take this one, so if we write sine inverse x equal k, sine inverse x equal sine k, and this becomes x, so x is equal to sine k. So when a sine value, always it will be in the range of 0 to minus 1 to 0, minus 1 to plus 1. So we know sine x goes like this, right? So it will be in the range of minus 1. Yeah, so we can say part A, the answer is x is greater than or equal to minus 1, less than or equal to 1, right? Part B, express in terms of cos k. So here we found right now for sine k we have found the expression, and part B, right? Part 1 we want cos k. So cos k we can write as, right, square root of 1 minus sine squared k, right? So or else we can do like this, the normal method, right? Sine squared k plus cos squared k is equal to 1, and then cos squared k is equal to 1 minus sine squared k. So cos k is equal to square root of 1 minus sine squared k. So the answer would be sine squared k is x squared, so that would be 1 minus x squared, right? Same way, now they are asking tan k. So tan k we can write as, I will write it here, hope you all can see. Part 2, tan k is equal to, right, tan k is equal to sine k over cos k. So that will be x over cos k, square root of 1 minus x squared, right? And then part B, it's part C, it's asking how will these answers will be changed, right? So these answers will be changed if this range becomes, right, if this range becomes k is less than k is less than 0 and greater than minus pi over 2. So that means if the this one in this range, if k, right, so actually sine inverse x, right, then this will become actually, I mean whatever answer, right, it will become a negative value, this one negative value, but cos values are always same, so actually no change for this, even the sign, but here tan will become negative, right, but still the expression won't change, right? So automatically, I mean they are asking not the sign or anything, what would be the I mean the expressions. So when in this range, if you have a right angle triangle, same way when it goes to this one also, it will form a right angle triangle, and still Pythagoras theorem will give these expressions, right? Automatically these values will change, I mean according, but this expression won't change. Question 18, page 65, they have given a, I mean given this function, and it says the x is in this range, right, and also gx given this one. So they are asking us to sketch, so our I mean part A, they are asking us to sketch fx. This is our normal thing. So what we have to do is like this, domain -1 1, right, and it goes like this. So this one is pi over 2, right, this range, and the other one is minus pi over 2, right, and they are asking us to sketch this one. So this is x transformation, I mean when it get double it becomes half, so the same graph will become here minus half, this is half, and same minus pi over 2 and pi over 2, and it will hold this shape, right, and they are asking us to now part C, they are asking us to define g as in this way. Actually in the question they have given fx also in this way. So what will happen is, if we put, I mean 2x means, right, if you put 2x here, it will become sine inverse 2x. So here sine inverse 2x, and now they are asking to define the inverse function. So inverse function of g. So first we will do like this, we can say gx is, right, gx is equal to what, sine inverse 2x, and then we can this is actually y, that's how we do y, and then we will change the x and y, we will put here x sine inverse 2y. Both sides when we take sine, we get sine x is equal to 2y, so we get y is equal to half sine x, right? So the inverse function will be half sine x. We will do the question 9, right? So they have given the x is in the range of 0 to 1, right, x in the range of 0 to 1, right, and they are asking us to prove cos inverse, I mean 0 to 1 means now in this range, right, so both are sine and cos are in this range. Then what we can do is, right, so cos x, right, we will take cos inverse x, right, we'll say let y is equal to cos inverse x, and then we can say cos y is equal to x, right. So now we have to find sin y. So if this is the case, cos y is this, sin y is, we will say cos squared y, right, cos squared y is equal to x squared, right, cos squared. So here we can write this is equal to 1 minus, right, 1 minus, or else 5, mark is not writing. So here we get this into 1 minus sine squared y is equal to x squared. Sine squared y is equal to 1 minus x squared, and sine y is equal to square root of, actually here we get plus or minus 1 minus x squared, right? Now this one, right, so if you take 0 to 1, if x is 0 to 1, right, always cos inverse and sine inverse both are positive, right, positive values. And then y is equal to square root of 1 minus x squared. So here y we can write as, here y is sine y, and here we can write y is equal to, right, sine inverse square root of 1 minus x squared, and y we can substitute from here cos inverse x, right, cos inverse x is equal to sine inverse square root 1 minus x squared. Now the part B, right, they are asking if the range is minus 1 greater than or equal to x, less than or equal to 0. If x is in this range, why this it's not true. The reason is, if you take minus 1 to 0, right, cos will be actually in this range, right, and sine inverse will be in this range. So actually then it can't happen, right, because they doesn't the solutions are not in a common area, right? So you can write that reason.